All right. The last thing I want to talk about as far as gravity is concerned is tides. Now, there's naturally some misconceptions about gravity, but I'll let that go until the last chart here, and you can look at those things on your own. The misconceptions are kind of fun to come across and discuss, but we'll see one of them in terms of tides. Tides are caused by gravitational objects, and it basically has to do with the fact, at least for tides on the Earth, that it has to do with the fact that the force of gravity that the moon is creating upon the Earth here is different than what it is over here. The Earth is being moved by the gravity from the moon, and it can be expressed in terms of what's going on with the object right here. So the force of gravity causing the Earth to move is larger over here than it is over there. But this is the center of mass of the Earth, and therefore the whole Earth is going to move this way. Now, liquid water is not really attached to the Earth in the sense that that the water is free to move. Okay, so what we'll see is, one of the thoughts one could have is all the water is going to be pulled off of the Earth towards the moon over this way, and everything is going to be showering the moon. Now, that isn't the case that happens at all, because the Earth would be moving this way as well. So it just doesn't happen that way. Okay, but here we go with, pictures of tides, like around in Nova Scotia. Typically, there are two tides, too high and too low. Okay, and they are associated with the moon. You can watch and see where the moon is relative to the tides, and they go hand in hand. Basically, the moon goes around the Earth a little bit more than in 24 hours. And that is how the tides work. We say every day that there are two high tides and two low tides, but it's a little bit more than that. Okay. All right, so here's the basic idea here, right here. Closest to the moon, we have the strongest pull. So things are dragged towards the moon. And the things that are furthest away from the moon feel the weakest pull, and so they sort of float away, if you will. Okay, so here is the perspective, that I just showed you in the first chart, where here you have a big arrow, but it's not as big as this one, and here you have another arrow that is smaller than this one in the center, and here you have arrows in this direction and that direction. Now, if you consider that you are on the Earth, okay, you can go into a frame of reference where you take out this force here and apply it to everything. And if you do that, you get a squishing of the Earth from top and bottom here in this picture, and you get a stretching or pulling that goes in this direction on this side and goes in that direction on that side. Okay, we'll see this as important when we're talking about the moons of Jupiter as it goes around Jupiter. So much so that on Io, it causes the interior of Io to be molten, and it's the most volcanic place in the solar system. All right, here's another picture of what's going on. Just another picture of what's going on. And here's another picture of what's going on. They're all doing the same thing. So in this particular case, the water is flowing from here out to here, filling up, causing a bulge there and on the other side. Okay, now, tides and water, the coastlines affect it. In most cases, we do have two high tides and two low tides, but there are certain locations where the coastlines cause changes. So Nova Scotia is one. The Thames has a tidal bore going up it. And, it'd be kind of fun to surf those things. So here is, a famous spot in France. So here is, at low tide, and I hope all those people were able to drive away. So here's another picture of that. I have to go there one day. All right. So here are some questions you might want to think about. And then the sun has an effect on tides on the Earth. The sun is very massive, but it is much further away. The effect of the sun is about a third of that of the moon, or maybe half of that. And so when the moon and the sun are lined up, we have a spring tide. Spring as in, things that, stretch and, spring on the scale, things like, those types of springs. I don't mean spring as far as the season is concerned. And then we have nip tide when the moon and the sun are perpendicular to each other. Okay, so the tides are not nearly as strong, and neither the high tides are high and the low tides are not all that low. So everything's sort of standard. Okay, so to give you thinking about this these ideas, draw pictures of the spring and the nip tides. Looking at the moon and the phases of the moon, right? So we're talking about the orientation of the sun, Earth, Moon system, and then also, draw the pictures of these things as it says here. So this would be a your turn thing to consider as far as the questions and the discussion of the topic. I like this picture better. Okay, now there are consequences to these tides. If you're moving around, if you have all this water moving around, and you're causing it to move, you know that the water is going to heat up. I mean, not a huge amount, but it's going to heat up a little bit. And there is an effect caused because of the Earth's rotation, right? The water is connected to the Earth, and as the Earth rotates, then this bulge is going to move with the Earth, right? I mean, if you think about it, you have a cup of water, and you swing it around, you're going to swing the cup of water around, right? And that's what's going on with these bulges of water around the Earth. And so, because of the fact that they are out of sync with the moon, right? Because here's where the bulge is, and here's where the moon is, we're going to set up a torque. And so there is a tendency for this amount of water here to cause a torque to twist the Earth in this direction. Over on this side, there's going to be a torque to push the Earth around this way, to speed it up. So this one would slow it down, this one would speed it up. And since the force due to this water is closer to the moon, it's going to be stronger. And this side is going to be weaker. So the stronger torque is going to cause the Earth to slow down. These two torques add up, this one being big, this one being smaller, and so the overall effect is to cause the Earth to slow down. And you can see by how much it slows down. Not very much. We call those leap seconds. Okay, so tides have long-term effects. These bulges do affect the Earth. The friction gets converted into kinetic energy, which turns into heat, and so the Earth slows down. Okay, the Earth is much smaller, and it is already slowed down already, and that's why we have the same face always pointed towards the Earth. And if you look in details about the moon, actually the moon sort of sticks out on the Earth's side. Okay, so tidal locking is what it's called, and that's why we see only one face. The moon does rotate around its axis once every month. Okay, so saying the moon, because we're looking at the moon only one face, does not mean it is stationary. With respect to the sun, it rotates on its axis. Okay, so here is a couple of links for you to take a look at. One is on misconceptions, and then there's one on some animations of this thing. Okay, that's all I got on tides.